Greetings all. My name is Tlakale Mogebisa and I am a CSIR employee and under the Climate Modeling and Air Quality Group. And I'm also a PhD student at the University of Pretoria. And I will be doing presentation on my PhD work, which is entitled ESM Forced High Resolution Seasonal Wind Speed Predictions and Implications for Renewable Energy in a Changing Climate. As part of my presentation, I will go on to look at the introduction, the importance of reliable wind speed predictions, seasonal wind speed prediction applications that have been used around the world, and go on to review different types of prediction models that have been frequently used, and then finally look at the envisaged study approach. All right, so the importance of wind power in the energy sector for the sustainable and green future cannot be overlooked. The generation of electricity accounts for about 70% of the emitted greenhouse gases through fossil fuel combustion globally. Therefore, the deployment of wind power has provided and keeps on providing access to renewable and ecologically sustainable energy source that is an alternative to fossil fuels. And this alternative is less expensive, it is consistently available, and most importantly, its proliferation goes on to inform progress in the implementation of global climate policy, and in doing so also inform future climate change decision making. So because of these reasons, there has been a growing number of cumulative installed capacity of global wind installations with high rankings in countries such as the USA, China, as well as Germany since 2019. And in the year 2018, wind energy accounted for about 4.8% of electricity production globally, and it is by far continuously growing. However, the generation of wind power, is a complex process that not only depends on environmental factors, but also requires numerous technical developments. So wind speed, for instance, is a very fundamental variable in this aspect, in the wind energy sector, for the operation of wind farms, which for the use in wind power generation. The variable is, however, influenced by multiple factors in the region, such as your terrain, your temperature, your air pressure, your wind direction, etc. And with future, and therefore with wind speed, with the production of wind energy being highly influenced by weather conditions as well as climate variability, future projections for wind energy have therefore shown that climate change has the potential to alter the characteristics and the variability of wind speeds on a seasonal timescale, and this will have high implications in the production of wind energy. Hence, there is therefore a need for high resolution wind speed prediction systems to capture these variations and cycles of wind speed, and in doing so, improve the predictive modeling performance, which will enforce effective, which will enforce or foster effective use in informing renewable energy planning, operations, and management strategies in the changing climate. So, a lot of these model predictions have a lot of errors. So it is, which is why it's important to select or to use a model that can be reliable, to produce wind speed predictions that will not have a lot of errors, since errors can cause very detrimental financial implications. For instance, Showman 2022 highlighted that a 1% error can account to about $12 million in losses. So therefore, it is of great importance that wind speed prediction methods are reliable, or the wind speed simulation product or output is reliable for use and application in these in the different applications, excuse me. So on this slide, I go on to show the different applications. So as highlighted by or outlined by different studies. So these will include your wind farm operation planning, the planning of the electricity generation units for maximum power share, enhancing the evaluation process of wind speed characteristics for informing efficient and renewable and reliable energy applications. And another one is for better economic dispatch planning and reliable transmission system operations. So these are just a few of these applications. Yeah. So then on this slide, we go on to review the different types of models that are frequently used. So multiple studies have applied different models for predicting wind speed over the years, and these listed here would include your physical models, your statistical and computational models, hybrid models, as well as most recently your artificial intelligence and machine learning models. However, the outcomes of the different studies have generally been vast, as I've mentioned, due to different reasons, including the fact that they apply different the listed different kinds of models that are used, the different downscaling techniques, different emission scenarios, because different models have different parameterization schemes and different resolutions. So these tend to affect the output of your model. Therefore, in order to reduce these negative impacts or these disadvantages, it is of great importance to therefore select a model that will be able to capture and reproduce specific observational characteristics such that accurate and realistic outputs will be produced for informing wind energy planning, policy, and assessment for wind power generation and operations. Because multiple studies have commended the use of hybrid models and that are further combined with artificial intelligence technologies, the study therefore looks forward to applying these hybrid models, as well as in coupling them with machine learning technologies. So this study will be the study will be focused over Southern Africa, as well as a zoom into South Africa. And the data sets that will be used in the study will be observed as well as reanalysis data to cover both the Southern Africa boundary as well as South Africa, and they will both the two regions will look at the near surface as well as the upper surface levels for a period of 15 years, ranging from the year 2007 to 2020. And this data will therefore be compared to model outputs from the CCAM model, also in monthly data, wind speed over the same heights and the same period. All right, so what the methods that will be implemented in this study include that both the observed and reanalysis wind speed data sets will be used to estimate potential wind power generator outputs, and then an ensemble of process-based models and data-driven models. Model forecasts will also be used to estimate potential wind power generator outputs, and then we furthermore, the observed wind power generation fields will be used for bias correction to remove or reduce the systemic errors in the models, so that it's better, it performs better in reproducing the observation. And then finally, the study will go on to validate the model outputs with wind power outputs from actual wind power generation sites. Yeah, so that is the proposed study that I am currently working on, and that is the end of my presentation. Thank you.